All right. Good afternoon, everyone. Thanks for coming to our session, XNT306. If you're a .NET developer or an architect or somebody who's interested in knowing about taking your existing .NET applications and modernize them using microservices architecture, then you're in the right session. My name is Runit Vishisht. I'm a solutions architect at AWS. And in today's session, I'm joined by my fellow speakers, Rashid Abdul from AWS and Odell Turtle from Avionté. You will hear from them in just a few minutes. So in today's session, we're going to talk about things to keep in mind while choosing between monolith versus microservices architecture for your .NET applications. We will talk about lessons that we have learned while working with multiple customers, helping them take their monolith applications to microservices on AWS. We have tried to break down these lessons into 5 different subsections that we will share with you today. Then we will have Odell talk about Avionté's journey modernizing their .NET applications on AWS. To refresh the idea of microservices for everyone, it is an organizational and architectural pattern for developing software applications, where your software is comprised of multiple independent services which communicate with each other over well-defined APIs. These independent services can be developed, deployed, and managed independently from the rest of the application, as well as it can be scaled, decoupled from the rest of the monolith application as well. Now, why would you do this? This allows developer to own a service, manage it, deploy it, debug it, and scale it independent from everything else. Now, for the sake of this discussion, let's say that we have an online store developed over the period of multiple years. This store has gradually grown to become a really big application, and the usage of this application has also considerably grown. This application was developed using ASP.NET 4.8 on the application side and Microsoft SQL Server on the database side. Now, as the application's usage has grown, the organization has run into multiple challenges with the application, mostly to do with the high availability of application, scalability, and the performance of applications. I'm assuming few of you can relate yourself with this application architecture and some of the challenges that this architecture might pose. Now, to help this organization improve their performance, their scalability, their fault tolerance, how can we help this organization? Well, it's very much possible to think about microservices right away. Perhaps this organization can create their application or break their application into microservices and move to the cloud. Do you think this can solve all the problems? Maybe it will. Maybe it will not. How would they know whether microservices is the right solution for them or not? Well, the very first lesson that we want to share with you based on our interactions with our customers is, before jumping to any architectural decision, especially technical architectural decision, the very first thing that we need to do is understand what are the business priorities and what are the technical goals that you want to achieve or problems you want to solve for your application in the first place. Maybe the challenge is availability of the application. Maybe you want to improve the overall availability and stability of the application. Maybe application is not scalable enough, especially when it comes to special sales days, such as Black Friday. Maybe the organization's challenge is that they want to increase more features more frequently and increase their time to market, and they think microservice architecture is the right way to do it. Maybe the application does not have mobile experience today, and the goal is to create a mobile experience through microservices architecture. The application is built using ASP.NET 4.8, and the database is SQL Server, which means it has high dependency on commercial software such as Windows and SQL Server, which means as the application is growing, maybe the overall cost of ownership of application is growing proportionally, and that could be the goal of the organization, to reduce overall cost of ownership. Application is built using .NET Framework, which is great, but Microsoft has announced, I think it's been 4 or 5 years since .NET Core, or now known as .NET, is going to be the future of .NET. Maybe you want to go from previous version of .NET Framework to .NET, and microservices is an opportunity for you to modernize and upgrade your .NET version as well. And you want to do all of this while using existing developer skill set. You don't want your developers to start learning new technologies. You want them to be able to use as much skill set they can while the application is still compliant and secure. Now, microservices can help them achieve all of these goals, or maybe most of those goals. But there is more than microservices, more patterns or approaches than microservices, which can help customers achieve some or all of those goals as well. So let's take a few minutes and look at some of those approaches. The first approach is rehosting to the cloud. In the rehosting architecture pattern, you can take your existing ASP.NET application and deploy it on EC2 Windows-based instances, but spread them across availability zones in an AWS region and put them behind an application load balancer. By spreading your applications across availability zones, you will get fault tolerance and high availability by this architecture pattern automatically. Now, if you include EC2 auto-scaling with this architecture, you will also be bringing in scalability, which was not possible in the on-premises system. What about database? Well, same thing can be done with databases as well. Existing SQL Server can be moved to AWS, and SQL Server cluster can be spread across multiple availability zones. Multiple availability zones, though they are physically separated from each other, but the networking between availability zones support low latency and high throughput, which can allow even synchronous replication between SQL Server. Now, this architecture can provide fault tolerance, some sort of high availability, as well as scalability, but there are some challenges still present. It's still running all on Windows, so no change in the cost. You're still deploying on virtual machines, even with auto-scaling. The unit of scaling is still EC2-based instances, which is still virtual machines, so they're not going to become available and start serving traffic right away. EC2 instances are going to take some time to become available. So it is scalable better than on-premises, but not really as scalable as you may like to do. So what are the other things you can try? The next one is replatforming. This pattern is highly beneficial when you cannot port your applications to latest version of .NET. What we suggest is containerize those applications to Windows container and run them on managed container services on AWS. I have 3 container services here, Amazon ECS, which is a managed container service. You build your application, build the containers, and ECS will be responsible for creating the compute environment to run, deploy, and orchestrate those containers for you. EKS is same as ECS, except that it is based on Kubernetes. So if you're inclined towards using Kubernetes in a managed service on AWS, EKS is that service. AWS Fargate is serverless containers, which can allow you to deploy your .NET containers in a serverless fashion. We support Linux containers both on ECS and EKS with Fargate, and Windows containers with Fargate on ECS. Now with containers, you can increase your application density, reducing some cost, improving some performance, as well as container images being smaller in size as compared to Windows virtual machines. They can come up relatively quickly and can become ready to serve the traffic quicker than virtual machines. You can include your containers in auto-scaling group as well. So just like EC2 instances, you can make your containers scalable as well. The third thing you can do with containers is containers allow you to optimize your deployment automation. You can start adopting modern software development practices such as DevOps and deployment automation using CI/CD pipelines, which can eventually improve your time to market. Developers can check in code more confidently, deploy code more frequently, and this is where containers can help you. If you're new to containers, AWS's command line tool called app2container can help you extract your existing ASP.NET applications from Windows instances, containerize those applications for you, and also generate deployment artifacts targeting ECS, EKS. And it does all of this while following the best practices. So if you're getting started with containers, Windows containers especially, app2containers can be the utility that can help you. Now, one more pattern after rehost and replatforming is refactoring. If you don't have hard dependency on .NET Framework, we strongly recommend you to port your application to .NET Core or just .NET first. What this allows you to do is, because .NET is platform agnostic, you can right away start hosting your .NET applications on non-Windows platforms such as Linux. Now, this right away brings down your overall cost of ownership. Windows licensing cost can be sometimes as much as 30% of your overall cost. So just by porting your application to .NET and running on Linux, you can save that cost. Linux images tend to be smaller in size, which means, remember, I talked about auto-scaling for Windows containers and before that EC2. Linux containers can work with auto-scaling way better than both of them. They can become available in the matter of few seconds and start serving traffic. So without modifying your application structure, just by porting and then containerizing to Linux container, you can start getting advantage of scalability and performance, and of course, cost. Not to mention, every new version of .NET is performing better than the previous version. Microsoft is spending a lot of efforts and time making .NET better. Every version is performing better than the previous one. So just by upgrading it to the latest version, you can get these benefits. Every version is coming with new version of C#. You can take advantage of latest features. And last but not the least, if you compile your applications targeting ARM64-based processors, in addition to all of these benefits, if you run your applications on ARM64-based Graviton processors, which are custom processors developed by Amazon, you can run them on services such as EC2 or container services such as ECS, EKS, powered by Graviton. It gives you additional 40% to 60% price performance advantage, which means till now, whatever we've discussed, without modifying your application, you can get all of these benefits, which can go back to the business goals that we talked about. And to help you with this, you can also look at AWS Toolkit for .NET Refactoring. It's a Visual Studio IDE plugin, IDE extension. From within the Visual Studio, it can help you scan your .NET Framework applications. It can tell you how much of your code is compatible with .NET latest version. It can even make code changes on your behalf and lets you test and validate your application from within Visual Studio before you're ready to deploy it in production. And there's a QR code if you're interested in knowing more about AWS Toolkit. Now, once you have ported it to .NET, you can, of course, run those Linux containers on same container services that I mentioned, or you can also take advantage of managed service called AppRunner. AppRunner is a service which you can point it to your source code repo, your .NET source code repo, and it's going to fire off the build process, provision compute for you, deploy your application, and give you a secure endpoint. Highly suggest you to look at AppRunner as well as an option. Now, although replatform and refactor can take care of a lot of things, but there are still some challenges which it cannot solve. For example, your application will scale as a monolith. Even after all of these changes, if you have to scale your application will scale as a whole. Second, if you're making changes in one part of the application, you still have to deploy the whole application as it is, which means every single change would mean whole deployment again. With microservices, if you're able to break these applications out, your services can scale independent from each other, and you can debug and deploy these applications separate from each other as well. So to talk about how to go from monolith to microservices, I'm going to invite Rashid to walk us through the next section.
Thank you, Ronit. My name is Rashid Abdul. I am the product manager for AI-powered refactoring services and tools for .NET. So in this lesson, we are going to focus specifically on the problem of taking a monolith and breaking it down to a microservice-based architecture. And we have a tool for this, and we will go through that as well. So to get started, so when we talk about, when Ronit gave the example of a traditional application, we are talking about a scenario where maybe this is an application that you inherited. You didn't write it. Maybe this was written decades ago. You just inherited it. So you are trying to figure out all the business domains in the code before you start to break it down into smaller pieces. So there are three distinct approaches. The first one is more of a theoretical exercise, which is the Big Bang approach, which is essentially you take this application, you are going to analyze manually, you're going to take a look at all the business domains, you identify them manually. This assumes that you already know the application end-to-end pretty well. This assumes that potentially you are willing to take a downtime. Maybe you are going to have a specific development environment where you're going to break things down. But for all practical purposes in large enterprise applications, Big Bang doesn't work. The other approach is, because you don't want to touch these business critical applications, the other approach is maybe when you are adding new capabilities, you're going to add them as microservices, so you're not touching the original code yet, and then you are layering that around it. So this way, your new features and capabilities get to take advantage of the native AWS architecture, whereas the old one runs in an EC2 instance. The best approach we recommend is a third one, which is a Strangler Fig approach. So in Strangler Fig approach, it's a combination of the Big Bang and evolution approach, because there is a blast involved, but the blast it's a controlled blast within a specific domain. So you again go and identify the domains, and we will walk you through a tool that helps you with that. Once you identify your business domain, then you go and blast one domain at a time. You extract them, run as a separate service. You create a service mesh. You make them talk to each other. Then you go and attack the second one. You keep doing this until all the domains are extracted, and you're left with the glue that was essentially a switch that glues everything together. That remaining layer, you can rewrite. And we'll walk you through how this works in the Strangler Fig architecture. So going back to Rooney's example, let us say you have this e-commerce application, this fictitious e-commerce application that was written a long time ago. So you're looking at a blue box, which is your monolith, ASP 4.8 MVC application. Then you have this is backed by Microsoft SQL Server. So in a scenario like this, as you're shining a light on the blue box, you're really trying to understand the bounded context in the code. You're trying to understand the domains and business domains in the code. As an example, so here in this specific example, you're seeing an orders context and a shipping context. Think of like two distinct business domains. So the objects in orange or objects in yellow that you see, they're specific to that domain. Whereas the objects in pink, that's common across them. So the big idea here is that so long as the method contract between these two bounded domains are the same, I can modify anything on the left-hand side or on the right-hand side, and still the user experience will not change. You're practically re-architecting through refactoring. So to follow this idea, so really going back to our original application, imagine for the sake of discussion, we will talk about the tool in a minute, you shine the light and you identify the business domains. So in this example, so we see this shipping, orders, inventory as the business domains, and then we are kind of calling UI as a separate domain in itself for functionality reasons. So now you can see some of the things that Rooney talked about in terms of performance and scale and the cost. So now you're looking at a scenario where if I could extract, say for example, inventory, and if I'm able to scale that independent of the rest of the monolith, now maybe during a holiday sale time, I can scale out my inventory ahead of the holidays. During holidays, I can scale out my orders as a subsystem. And maybe post-holidays, when shipping is going to be busy, is when I'm going to scale out my the shipping container. So in order to establish this, you want to extract. So what you are doing in this case is, following the Strangler Fig pattern, you're going to extract the code that belongs to the shipping domain, and you're going to couple that back to your monolith using what you call an ACL, the anti-corruption layer. Anti-corruption layer is nothing but an adapter. What it does is it glues your modernized code back to your monolith, and they can work in tandem while this process goes on. And if you watch closely, you see another problem in this case, which is although you have extracted code and you have a microservice, it is still glued at the hip to the same database. But the general wisdom about microservice-based architecture is that the microservice should be independent. It should be able to run on its own. So which means you may want to also establish what is called a CQRS pattern, which is a command query segregation response pattern, where maybe now that I have modernized my shipping code, maybe I will put this behind, say in this example, DynamoDB. And now what I'm establishing here is that all the shipping transactions are tracked in Dynamo, and then eventually consistent. Maybe you can use a Lambda as a way to replicate this back to production at your own SLA, because there is no business reason for you to have atomic capability for the end user to see the shipping details. Maybe your SLA is in such a way that I'm going to update it every 1 hour, 10 hour, 1 day. So why do we need to have the same capacity, same performance for the database when maybe a smaller footprint will do? So this way, you have completely decoupled your microservice from your original architecture. Then the rest is you keep doing this over and over. So for example, so you have migrated applications. So this is running in EC2. EC2, we already provide the ability to, from the client connection standpoint, so you do have the application load balancer that meets your need. Now, you extracted one service. You refactored it. You went through all this process. And you're comfortable. You have declared victory. Then you go ahead and extract the second and the third. You keep doing that until you're left with UI. Because when it comes to UI, probably, like Ronit mentioned before, maybe you're trying to improve the customer experience. Maybe you're looking to create a mobile experience. So you may want to rewrite the UI altogether, now that all the business services are decoupled from your monolithic architecture. So this way, you could reuse all your code. You're essentially refactoring your business application and maybe rewriting the UI layer for the modern experience. So this is great in theory, but how do we do it? So this is where we have a tool. So the tool that we want to introduce to you is a microservice extractor for .NET. So what microservice extractor does is it actually helps you in both this part of the journey. It has got a dual role. It is an insightful advisor. As a software architect, it tells you, it analyzes your code and helps you identify the candidates that are extractable. It analyzes your code, it analyzes your classes and dependencies and figures out what classes belong together. So it groups them for you automatically. It's an assistive tool. You can take a look at those recommendations, you can accept them as is, or you can modify them, fine-tune them. Once you have created a group of classes that belong together, the tool actually helps you extract that code into separate solution file projects. And once those are created, and when it is doing it, it also takes care of all the it brings the dependencies with it, so you can build them as an independent service. So to give you a little bit of a walkthrough about this product is something towards the end of the session, we will point you to a workshop where you get to play with this product and experience this in real time. But let me give you some context on how this product works. So the first part, the insightful advisor role, is AI powered. So this tool is cloud, it's a Windows application, but it is cloud connected, it's connected to AWS. And what it does is, behind the scene, it is using AI as a way to analyze your application's architecture and creates those groups for you. It will identify what classes belong together. Once you create those, you right-click. So in this case, the example you're seeing is you right-click on the shipping group. Now, when you right-click, it gives you the option to extract the code, or you can do extract and port at the same time. Like Ronit said, once you have extracted as a new service, a control service that you're going to give it to a specific team, why stop at just extracting? You can port at the same time. That way, the extractor service can be run on lightweight Linux containers rather than heavy Windows containers. So the tool provides you that capability as well. Once the extraction is complete, so this is how the UI will look like. It will actually give you a path to your source file, the extracted code, and the modified monolith code. This is important because the tool not only gives you the solution file for your extracted code, it gives you the option to modify your original monolith to make use of that service so that all the local instantiations of the classes that was in your original monolith, now that they are extracted out, they can be replaced by remote invocations. So to do this, so let me give an example. So here is the extracted code. So in this case, what you're looking at is an extraction of the inventory service. So you'll see that once the code is extracted, microservice extractor is actually taking care of a bunch of things. It created a service. I don't have a pointer. It created a service. And you also see that it brought all the data layer dependencies along with it, such as the EF, as well as the DB context. All those things comes with it, because the goal is to give you a piece of code that can run on its own. And in addition, so you're also seeing that, so there is the way this is established, is that by bringing those dependencies together, you can build this. And you also see that there is a specific controller that got added here, which is the API controller. So essentially what the service has done, what the tool has done is, it is creating an experience where all the public methods of your original set of classes is now served as RESTful APIs through this service. So once this is established, if you go back to your original monolith, the residual monolith, now you see that there is an anti-corruption layer. The one that is highlighted here is really the remote routing. So by default, it is set to true, which means now you're routing to your microservice. But if you're not ready, if the team is not ready, if the team is still working on your residual monolith, then, the extracted code, you have the ability to set that to false so that the monolith will continue to function as if nothing has happened. So it gives you that flexibility. And you also see a connection string. So the reason, so when you're running the extracted service, so you're going to run that on a specific port. And if you put that port under the endpoint here, now this monolith will start to use your extracted service. And you keep doing this over and over for everything that you extract. So to give you some context, going back to the 3 methods, the beauty of microservice extractor is that it gives you the ability to provide that insightful advisor role, that is to really look into the code, identifying the domains, and identifying extraction candidates. This is needed no matter which approach that you take, right? So it's available to you right now. And then when it is big bang approach, you are going to do all the extractions in one shot. If it is evolution, you're not doing extraction at all. Because remember, the idea is that you are not trying to touch your original monolith. But still, in order to wrap new services around your existing service, you need to understand the business domain. So still, the tool helps you with that. And when it comes to Strangler Fig pattern, you're doing this one at a time, and you're adding that ACL layer, the branch by abstraction layer, and then you switch over when you're ready. So it gives you the flexibility that enterprises need, where I want to extract it, but I'm not ready to deploy it right away. You want to do fine-grained porting. You do that, and then you repeat this over and over. So this way, you're able to kind of strangle your monolith gradually, get all the business functions out of it, and whatever is left, you can rewrite. So in many cases, probably when you folks are doing this, maybe you want some help. Maybe you have a day job of actually supporting all these business applications, and refactoring and re-architecting is not something that you want to do. We have AWS partners who can help you in this journey. So some of the partners are here. Can our partners stand up? I think we have Chloe, we have SourceFuse. So all these partners, they have been doing this for years, and they can help you with these things. And they also have their own tools to help you with this journey. So you're never alone. So our goal is to help you modernize your applications with the tools that we provide, with the tools that our partners provide, the skills that our partners provide. And we hope you use this tool plus our partner services to take advantage of this. Now let's go to lesson 3. Rooney, back to you.
Awesome. Thanks, Rashid. So continuing with our modernization using microservices discussion, you heard about some of the patterns before microservices, then you heard about microservice extractor from Rashid. Now, a couple of other things to keep in mind based on our discussions with our customers. Microservices are sort of de facto, or when you talk about microservices, almost always our customers talk about containers, which is great. But a lot of time, containers would also mean Kubernetes for a lot of our developers and customers, which is totally fine if you come with a Kubernetes experience. But if not, I want to make sure that we call out that you can currently run .NET on container services beyond Kubernetes. We talked about some of these services already. We talked about AppRunner. One service we did not talk about is AWS Lambda. Lambda is a serverless compute service. You can build .NET-based application using Lambda. It is a great service which can be used for event-driven microservices invoked asynchronously. You can invoke Lambda functions from 200 plus AWS and our partner tools, partner software solutions as well. And you can run Windows containers on ECS, EKS, and Fargate, and .NET Core-based applications on these containers, as well as AppRunner and Lambda. Yeah, and you don't have to settle with only one compute service to deploy your microservices. You can choose, for example, your front end to run using AppRunner, whereas your microservices could be running on something like AWS Fargate. Or you can use mix of AWS Fargate to run few services and few other services running on ECS or EKS. It totally depends upon what services are you most comfortable with. That was compute services for you. Microservices discussion cannot be complete without talking about databases. Now, you might be developing microservices for maybe to cater to multiples of millions of transactions with the single-digit millisecond latency keeping in mind. Or you could be designing microservices catering to multiples of terabytes of databases, data stores. Or you could be designing microservices where your data needs to be spread out across the globe. Now, based on your requirements, what we suggest to our customers is think beyond just relational databases. Think beyond SQL Server. AWS provides multiple purpose-based databases. These databases are in category of relational database, key value, document, in-memory, etc. Most of these databases have a corresponding .NET SDK, so you can call them from your .NET applications. A couple of these databases are very popular when it comes to developing .NET microservices. Let's have a quick look at these databases. First one is Amazon Aurora. Amazon Aurora is a managed database service. It is fully compatible with MySQL and Postgres, which means MySQL and Postgres providers for .NET should work seamlessly with Amazon Aurora as well. The coolest thing about Amazon Aurora is it decouples compute from storage. Whenever you start with Amazon Aurora, you can start with really small storage, and as your data grows, your storage can grow correspondingly as well. You can go to up to 128 terabytes of storage within one Amazon Aurora cluster. Amazon Aurora would write your data, or it will create 6 different copies of your data spread across 3 availability zones, which means by default, you get redundancy and high availability with your data baked into your database architecture. Now, because compute is decoupled from storage, you can start with creating a cluster with only one compute instance or one compute node, which could be serving as both your reader and writer. But as the usage grows, if your microservice is heavy on read operations, you can create multiple read replicas for your Aurora instance. You can start with one node, and you can go up to 15 read replicas for a single Amazon Aurora instance. Now, my favorite feature about Amazon Aurora is Amazon Aurora Serverless. Because compute is decoupled from storage, Amazon Aurora can scale out compute on demand, just like you can do auto-scaling on your application servers. What that means is, if you're building a microservice, for example, order service, which should be able to respond to sudden surge in incoming order request, sudden surge in incoming transactions, Amazon Aurora Serverless V2 can scale as soon as number of requests go up. In this chart over here, what you see is number of orders in blue line. And as you can see, as number of orders pick up, Amazon Aurora Serverless V2's database capacity also goes up to accommodate for those incoming transactions. You would also notice that as transactions are going up, the database capacity unit is also going up. But as soon as orders would drop, we don't scale in the compute right away. We follow the conservative approach, making sure we are not clearing out buffer pools sooner than expected. That's why you see a stepwise decrease in the compute capacity over the period of time. So you can get benefit of both scaling out quickly, but scaling in gradually to make sure that there's no negative impact on your microservices. The next database is Amazon DynamoDB. It's a serverless key value database service. You start by provisioning your read capacity units and write capacity units. There are no servers to provision. It has full-blown support for .NET, different ways to for .NET applications to speak with DynamoDB. And as your usage grows, just like Amazon Aurora, you can choose DynamoDB to scale out for you and scale back in, or you can provision your read and write capacity based on your requirements. Very, very flexible when it comes to capacity provisioning. And based on how you provision it, it ensures that you get predictable read operations and write operations from the DynamoDB instances. Another thing to notice here is you can have global tables with DynamoDB, which can replicate your data across multiple regions in AWS. This is great when you're building microservices, when you need to have data replicated across different global regions in AWS. Last but not the least is Amazon Elastic Cache. This is for the use cases where you're building a microservice where the data doesn't have to persist. This is an in-memory service which supports both Memcached and Redis and allows you to store data in memory using either of those engines. It's a managed service as well, so you get all the benefits of managed service with Amazon Elastic Cache. Now, if I put it back into the picture where after compute, you're thinking of using purpose-built databases, maybe you want to use Amazon Aurora for your ACID-compliant ordered service. Maybe for product service to store product catalog, which is not changing very often, you might like to go with Elastic Cache for Redis for a very quick turnaround time. And for shipping service, where a lot of orders are getting processed simultaneously and you want predictable read and write operations, you might like to go with DynamoDB. This way, what you're going to do is you're going to use purpose-built databases rather than having one single monolith, making sure that your database layer is modernized as well. Now, there's one challenge with this architecture, though. I don't know if you thought about it or not, but this architecture is way more complex than the original architecture. What that means is if something goes wrong in one part of your application or service, it can become really difficult for you to detect that issue, detect that problem, and then remediate it. That's where the last lesson for the day today, which is observability. It's very, very important. It's the last lesson, but not least. Whenever you're thinking of going from monolith to microservices, you cannot not think about observability. Observability is all about making sure that your distributed application, distributed databases, you have right kind of data points, logs, traces, or metrics being captured as the request goes from one point to another point. Now, when you think about observability, there are a lot of tools, a lot of services, both from AWS, our partners, even on on-premises systems, that can be used with .NET applications. What we would recommend if you're thinking of modernizing using microservices is to go with OpenTelemetry. OpenTelemetry is implementation of open source protocols as well as different tools, APIs, and SDKs, which can come together and make your application both agnostic of where you run it. Any application instrumented with OpenTelemetry can run on-premises, on AWS, or anywhere else as well. And combining OpenTelemetry with AWS distro for OpenTelemetry, it will make sure that no matter where you're running the application, you can direct all the logs from that application into the service of your choice. This distro allows you to bring your logs into AWS CloudWatch, into AWS X-Ray, or even other services such as AWS Managed Service for Prometheus, or even partner solutions. Now, we spoke a lot about what you should do, what are the things to keep in mind with compute, with database, with observability, et cetera. What we want to do now is we want to bring in Odell, CTO of Avionté, who is actually going through a journey similar to this. And we would like Odell to talk about how their experience had been and what were the challenges. Thank you.
Thank you. Good afternoon. My name is Odell Tuttle. I'm the CTO of Avionté. And what you've been hearing about so far have been some really cool tools, practices, frameworks, services, and some best practices around how to modernize your .NET stack. But I'd like to talk about it just briefly from a customer perspective, as Avionté has been going through this journey now for a couple of years. So I'll briefly touch on who are we, who is Avionté, some of the driving factors that led us to move to AWS and drive down this journey, what it's been like what that process was like, and then our experience since doing it, and then a little bit about our future plans after this, what we're on now. But in the spirit of beginning with the end in mind, I'll spoil the end a little bit. It's a really good outcome. We're seeing 4 and 5 nines of availability across all of our services. Our performance has dramatically improved over the last couple of years, and we can scale far more than we ever could before. So we're super excited about where this positioned us, and a lot of the learnings that are coming out of this are being applied in the real world. So just a little bit about Avionté. We're a company in the Minneapolis-St. Paul area. We're a software as a service platform that connects people with work. In fact, we're one of the biggest. Together with about 1,000 of our large clients who are organizations that run on our platform, we fuel the North American economy and put food on the table. Last year alone, we processed $15 billion in payroll, and 4.6 million W-2s were processed through our platform. But it wasn't always great. Avionté had some challenges. This is an attempt at trying to gather what their architecture looked like a few years ago as we were uncovering the thing that had been built over a number of years organically and through some acquisitions, proprietary data centers, monolithic .NET code, and a number of other cloud providers. They had problems with performance, problems with deployability, ability to operate and maintain, problems with compliance, and many others. So I like that movie line, but basically that's the way we felt. We looked at it and we said, well, this isn't going to work. We know we need to re-architect the monoliths to make them more modular, to establish contracts, and we know we need to move the infrastructure. It needs to be modernized. So get in the cloud and bust up the monoliths. And so, we kind of had a couple of options on the table. We could invest in the proprietary data center infrastructure, or we could migrate it to the cloud. We obviously are standing here, which path we went down. Then you had the question of which cloud provider do you go to? And I've worked with many, and there are several out there. And we were on multiples at the time. It was a fairly easy choice for us to go with AWS. First and foremost, because they embrace any technology. They're not specific to a vertical stack. Their vision for future growth and innovation is, to me, unmatched. Like, example, why we're all here this week in Las Vegas. Quite a few reasons. Plus, we already had some capabilities in AWS at the time. So we started down the journey that the team's been talking about today, and fast forward just 2 years later, this is what our web infrastructure looks like today. It's all runs out of the US East region. It's all active out of 2 zones. We can lose a service, a server, a VM. We can lose a whole data center, and we have, and uninterrupted. We also have all of our data replicated to the US West region. For our particular industry that we're in is highly regulated, so disaster recovery compliance is super important, and we simulate that. And we are now SOC 2 Type 2 compliant. So a lot of the plumbing that the team has talked about today has been super helpful in getting us there. We also had a legacy component in our environment, an RDP-based back office infrastructure that you would have thought couldn't have been ported, and we also re-architected that into the same multi-AZ, redundant, high availability disaster recovery architecture using pods and RDS. Some other things we got along the way. In the process of this journey, our customers were pressing us for better access to data, richer information, more timely updates. So taking advantage of some of the capabilities that are in AWS now, like Apache Kafka streaming, EC2 obviously, S3, DMS, we were able to set up some real-time data pipelines, or two data pipelines, one real-time with a 1-minute SLA for running operational reports, and another one that aggregated and rolled into Snowflake, which is our OLAP database. And so this was something that we were able to roll out in the course of this journey, and it was super successful. Customers loved the access to data, and now we're in the middle of reorganizing it such that we can get the batch also near real-time. Some other things I think they were mentioned earlier, right away we saw a huge improvement in our ability to deploy because we could shift to a complete blue-green deployment architecture and full CI/CD delivery. This allows our developers to ship code, as much as 4 times a day. And we really needed this in order to do all of the wrenching of the infrastructure that we had to do to head down this journey. So that was a great one that came out of it. A little bit about how did our journey look. You talked about partners earlier. You don't want to jump right in and just move a legacy monolith. It takes a ton of preparation. We enlisted the help of AWS and AWS's partners. They worked with us. We analyzed all the infrastructure that we had, did inventories of it, did sizing and estimates, and then we spent time architecting and building it out. Then, of course, you have to figure out what phases, because it's hard to figure out which components can move on their own independently and figure out those kind of cleavage points. And then there's also figuring out the modernization strategy in general. Do we do it all at once? Do we move everything to platform as a service? How much do we do in which modules where? So we chose the path of lift and shift, followed by modernization after the fact. That allowed us to shorten the amount of time that we were in that data center, that infrastructure. And so that's what led us down the path we're on. So just a quick view of what that journey looked like over the past couple of years. So 2021, we spent still in our data center going through vision and scope with our CSP provider, using tools like CloudChomp to size and estimate what the infrastructure was going to look like, and then project planning it out. And then last year was, or the year, I guess it's the year before last now, in 2022, we spent that year basically doing the move. The first major web architecture components moved at the beginning of the year, and toward the end of the year, all the RDP stack moved as well. And tons of sequencing, working with teams, planning it out, and then building all the process tooling using AWS's tools. And then what we spent the rest of this year doing is optimization, consolidating some services, getting familiar with the environment, improving the security posture of the environment, and really focusing on kind of cost and tuning, because when you first move in there, you're oversizing everything to make sure you don't have an interruption. And now we're shifting into our modernization, which is kind of why we're all here, and figuring out how to take services and extract them. And we've got tons of demand for it across our product roadmaps. But what does the infrastructure look like today? So I told you earlier, an organization that at one point could barely get 3 nines. We have 4 nines regularly, 5 nines on most services. Many petabytes of data online being served in our online application as well as in our reporting and our dashboards. 1/10 of a second average response times, 500 hosts that serve up all of our application. And we're continuously shipping, so this deck's a few days old, but 729 deployments already this year, while serving close to 90,000 requests per minute at peak during business hours. So it's a big improvement from where we started. So where do we expect to go from here? Well, we're already digging in deep on AI with Bedrock. We've been using Anthropic's Claude to do semantic search transformation, so we can just ask questions and let it build our queries for us. We've also integrated Claude with Bedrock into our chatbot that does recruiter interviews. And there's a multitude of other places where we're starting to leverage AI. And then, of course, leveraging other services that are in AWS and pulling out plumbing that we were using elsewhere, so queuing and email and message delivery, a lot of security appliances. Search. We're looking at Kendra, possibly help us, and OpenSearch to help us make our searches more efficient, more accurate. It's our most used feature. And then, of course, the one that we're here talking about is modular architecture to allow us to scale and operate better. That means our team, our chief architect, and others are also here at the event, but they're looking at tools like the extractor to better identify the domain boundaries and how we can carve them out using AI and other services to make it less arduous. We're also now able to build centers of expertise within our teams with all the knowledge base that we have around the AWS team and their partners. And then, of course, the services we just talked about. And the monoliths, we had several key monoliths that were using the Strangler Fig pattern to wrap UIs and APIs around and slowly strangle them. So what our architecture looks like in the coming year or two is this. We have obviously our customer touch points at the top, all running through the AWS API gateway. We have a unified identity across all of our platforms, and as we acquire companies and build new modules, we have them integrate into it, and I feel like those are the 2 key tenets to being able to strangle and enterprise into services, is to have a unified set of APIs, RESTful APIs, and a common identity platform across all of your services, which will allow you to be able to call all of them. So then our teams are now looking at and going into the different cloud services like RDS, like Kendra, like Bedrock, and then looking inside of our applications and extracting these services out of the apps. So our talent services, our job services, our payroll, things like that, so that it becomes a platform as a service and microservice-oriented architecture that's more modular and that we can update and maintain over time and quality is improved. So that's really our story, and I really appreciate the time to share it with you, and that's it. Thank you.
Awesome. Thanks, Odell. Now, to wrap it all up, we talked about 5 different things to keep in mind, starting with prioritizing your goals first or identifying your goals first, and then looking at different approaches, rehost, replatform, refactor. If none of these work, think about re-architecting to microservices. Then for microservices, we talked about a couple of approaches. We talked about different compute services, container services. Then we have App Runner and Lambda. Then we talked about how to pick purpose-built databases while designing your microservices architecture. Last but not the least was observability, and we briefly talked about how OpenTelemetry can help. Now, if you want to see microservices in action and want to try this yourself, we are doing a hands-on workshop on November 29th at level 1 here at MGM Grand. Our team, including Rashid will be, and myself will be there. If you want to, I don't know how many seats are available, but you can walk into this workshop as well. With that, thank you so much for your time today. We will be outside the room if you have any questions, along with our partners. So please come over if we can answer any questions for you today. Thank you so much for your time. I appreciate it.